Okay, so in this video, we want to review how to obtain the graph of a logarithmic function base a, but in the special case where the base is between 0 and 1. So let us first sketch the graph of the corresponding exponential function, and by reflection about y equals x, we will obtain, as we did in the previous video, the graph of the logarithmic function base a. Now the key difference here is that a is smaller than 1. So if you think about this, again, a to the 0 will be 1. So again, the exponential function will cross the y-axis when y equals 1. But now a is smaller than 1, which means when you take a larger and larger power of a number that is smaller than 1 but positive, this will grow smaller and smaller and smaller. Right? Think of 1 over 10. 1 over 10 squared is 1 over 100. 1 over 10 cubed is 1 over 1,000. 1 over 10 to the 4 is 1 over 10,000. So if you take a larger and larger power of a number that is smaller than 1 but positive, this will get smaller and smaller and very, very quickly. On the other hand, if you look at the negative x values, now you're taking the reciprocal. So if these values are small, these will be very large. And as these tend to 0, these will go to positive infinity. So it's really the reverse image of the exponential function when the base is larger than 1. And again, the y-intercept is y equals 1. So we now have the graph of the exponential function base a, when a is a positive integer, a positive real number, sorry, but is strictly less than 1. And again, as x tends to infinity, the y values are getting closer and closer to 0. Now for the logarithmic function, right, we're done with the hard stuff now. We sketch the line y equals x. And by definition, since the logarithmic function is the inverse of the exponential function, we simply have to reflect this curve about the line y equals x. So let's look at the sort of 2 points at infinity, to the right and to the left, to help us out. When x goes to positive infinity, y goes to 0 from above. So for the exponential we have infinity, 0 plus. And when x goes to negative infinity, y goes to positive infinity. So we have here negative infinity, infinity. And again, this is the point x equals 0, y equals 1, which will become, of course, for the logarithmic function, y equals 0, x equals 1. So we'll cross about here. The key point is that here, because y equals x, this point will not change, because if you swap x with y but they're equal, the point stays there. And now let's look at the behavior of the logarithmic function about the y-axis, right? This point is infinity 0 plus. So with the inverse it will be 0 plus infinity. So once x approaches 0 from the right, the logarithmic function will shoot up to positive infinity. We know again that this point is the point 0, 1, which will become the point 1, 0. And the last question is, what happens to the logarithmic function when x tends to positive infinity? Well, let's look back to the exponential function. The point negative infinity, positive infinity will become, for the logarithmic function, infinity, negative infinity. So when x gets to be larger and larger and positive, the y values of the logarithmic function will be more and more negative, so the graph will shoot down towards negative infinity. Right? It's not that bad of a mirror image. And now we have the graph of the logarithmic function base a, when a is some positive real number that is strictly less than 1. So again, anytime you want to sketch a graph of a logarithmic function, if you are not sure, sketch a simpler graph of the exponential function, reflect about the line y equals x, and you obtain the graph of the desired logarithmic function. And that's it.